start by looking at the review. So the biggest number that goes into 20, 4, and 12 would be 4. And they all have at least one R. So that's the GCF would be 4R. And the number of terms you have on the inside will match the number of terms of the question. So there's 3 terms, so we just have to find out what multiplies to get each of those. You get 5, you get 20, and then 2 more R's, R squared, to make R get 30. And we'll have minus 1. You don't need to really put the 1, and then R, make negative 4R squared, and then plus 3. Well, 4R times 3 gives you the 12. You can always check by distributing these back to see if they equal each of those 3 terms. Everything we're doing is really the reverse of something you've already learned. We're just trying to learn how to do all this stuff backwards. All right, and then right here, boxing of group. A grouping is when you just take the GCF of the first group of terms, and then you take the GCF for the second group of terms. And that's why they call it factor by grouping. You split it up into smaller groups, equal-sized groups. So GCF, and this is the same thing as we did right above. What's the biggest number that goes above? 7, and the highest exponent we can take out would be 2, because they both have, this has 3 x's, this has 2, so both of these have at least 2. So that's what we're going to take out. Question?
Could you just leave 7 outside and then put x on the inside?
No, that won't work. And because when you're doing this, for this method to work, these have to match. Right here. Right? And if you don't take out the x here, it won't match here because there's no x to take out on the 12, so it just doesn't work out. So it's key that both of those match. So from here, I know that one of my answers, one of my factors, is x minus 3 because they match. So if they don't match, then you will never get this factor. Okay? And we need one more term here because this does not equal negative 4x plus 12, right? So we need to put in minus 4 because that will give you negative 4x. That will give you positive 12 because negative is positive. And of course, these will equal these two. So our last term will be 7x squared, the 2 GCS that we took out. Now, we can have these in either order. It's multiplication, so since 3 times 2 is 2 times 3, the order here does not matter. I tend to put the higher exponent first, just out of habit, consistency. If you guys all do the same thing, when you guys are checking each other's answers, they'll be in the same order. It'll be just a little bit easier. Now, as I mentioned, you can use the box. That's the other method. It works just fine. It's a little bit easier if you're struggling or trying to make sure it's very accurate. You're not, you don't want any mistakes at all, because maybe you're prone to making little errors, and this will catch them. So use what you need to do accordingly. Okay. So you don't have to do both, but you end up doing the same thing anyway. So here we did, well, what's the GCF of the first two? That's the first step here, GCF of this first row. And it's still 7x squared. GCF of the second row, okay, would come out to 4. And then we have to figure out, well, what multiplies to equal whatever's on the inside where they meet. So 7x squared times what is 7x to the third? You'll get x. That's also the GCF of this column. And then if you do the GCF of this column, you'll get 3. Yeah. And then check the signs. So you can see here that we actually need this to multiply to negative 21. So this needs to be negative. So that's how the check is kind of built in, is that once you try to multiply it back together, it should work. And you can see here that we'd also need x times 4 doesn't equal negative 4x, so I'll make that negative as well. And then negative 3 times negative 4 does equal positive 12. So you can see check built in, and you get the same 2 factors. There you go, just like that. All right, so moving on. Let's look at number 5. if we started this the way it is, let's see how we do this. You guys know that we multiply these together, right? And we got 5x squared times 240. What that come out to? What is it? 1,200? X squared. Right? And that would have to, so two terms that multiply that, and they have to, let's see here, they have to add to 70x. So what two numbers work? Right? Not quite as easy, right? Not quite as easy to figure that out. So when this happens, think of it as a red flag that we're going to stop something. Something else could probably happen here and make life easier. Go back to what you already know. What did we do on the first step? We took out a GCF. It makes everything smaller. Right? So we have the 24, 12, you end up with 5, negative 1, and 3. Same thing here. Can you take out a GCF? Yeah. So do that first. And then all of a sudden, life becomes a lot easier. So we get x squared plus 14x. And use the calculator, 240 divided by 5 will be 48. So now, instead of using 1200 x squared is 70x, we only need to do, what is it, 48 x squared and 14. This makes life a lot easier. Same thing, it's just the same decision, right? But getting those two numbers is going to be a lot easier. So that's what the main difference is today, is that you'll have bigger numbers, and you're going to try to look for a GCF to take out. That will bring it down, make it a little more easier. Now, if you don't take out the 5, right, and you actually find the two numbers that work here, you can actually keep on going, and you'll still get the right answer at the end. It's just a lot harder to find the two numbers that work. Okay. You'll have to do a little GCF at the end of the problem instead of the beginning. But whenever possible, it's easier to do it at the beginning because the numbers are smaller. All right, so then you choose the method that you want to do. Let's say you just want to do grouping or do the box. Now you see I put this in parentheses because I don't want to forget about that 5. A lot of times people take out the 5 and they do all this work, and then their answer is just the two binomials they got, which is not the right answer because they don't multiply back to the original product. You got to have that 5 out there in front. That GCF you took out has to be in your answer as well. As long as you don't forget that, you're okay. So I kind of put it up here in front just to remind you. Okay, so we got what, x squared, and we got 48. And what two numbers did we come up with? 6 and 8. 6x, 8x. That's what goes in the diagonal here. In either order, doesn't matter. And the rest you already know. So from here on, this is just review. You know the rest of it. Yes. And there's your answer. There are your factors. In either order, but you got to have the GCF we took out at the very beginning, and then the two factors you got to the end. Now, if you want to use the grouping instead of the box here, right, you could use this. You can use this method, do the grouping instead if you don't like all the extra values of that. So either way, it's up to you. So you'll notice, especially as you go up in higher math classes, there's going to be different methods. The answers can be written in different ways, in different orders. You can't just look at somebody's paper and expect it to match perfectly with yours. There's going to be these variations. So part of it is learning that, well, you can write like this, or like this, or like this, and they're all the same. Let's see here. Should we do, let's do one more. Down. So let's set this up. So what multiplies 12 k squared and adds to negative 8? Negative 6k and negative 2k. Good? All right, now I'm going to do this by grouping. So 6k squared and my two right here, those on the right next. Instead of minus 8, I'm going to put minus 6 minus 2, which is the same as minus 8. But it gives us those 4 terms so we can do the grouping. So minus 6k. And then we got the plus 2. All right, find the GCF for the first two. Find the GCF for the second two. The leftovers from each should be identical. And if you prefer the box, you can be doing the box right now instead. You don't have to use it. In the long run, this is the method that you will gravitate towards after a while. If you're already using this, don't feel like you have to go back and learn the box and make sure you know it. That kind of goes away after a while. Because what's going to happen is that you'll get really good at the box and realize I really don't need to do as much writing anymore. When I was learning it, maybe I did, but after a while, not so much. So left over, we'll have k minus 1. You can always check. 6k times k should equal this. 6k times this should equal this. Know that the next one should be identical. K minus 1. And you have to find the missing number that will have you multiply the negative 2k plus 2. So that comes out to negative 2. Negative 2 times k times k. Yeah, that works. Negative times negative positive. So we have 6k minus 2 as 1. Right? That's the 2 GCFs. And the second factor in the answer is k minus 1. Now, how come this answer is not complete? This is not the full correct answer. Where? Yeah, so look at, is there GCF in any of these? Right? Yeah, so 6 and 2, you can factor out a 2 from both of these, so you got to do that. How come that happened? It's because the very beginning, we could have taken out a 2, but we didn't. So as mentioned on the first problem, if you actually found out what two numbers multiply 1200 and 70, you'll get two binomials, but one of them will have an extra factor of 5 that you wouldn't have to take out, and it would have matched this at the very end. So if you did this, you probably would come up with 5x plus 30 times x plus 8, right? And you would have had a factor out to 5, which would have given you this. But you can also, another possibility is that you would have got this, and 5x. That. So either way, they both have a factor of 5 that you can take out, and you end up with this answer. So it does not matter. It's just easier if you take out that factor at the beginning when it's a real big number. But like here, it's only 2, so it doesn't really make that big of a difference. You just take out the 2, go up to 3k minus 1, and then can't take anything from k minus 1, that stays the same. There you go. All right, little reminder, I'm going to let you guys work. What do these mean? Okay, so I'm going to go back and cite this over and over and over so we don't forget that these are the starting and ending or launching and landing points right here. For something going up in the air and coming back down. Now that we have this GCF up front, I got 2, what would that do to the graph? How would that affect it? It just makes it go taller, but it start from the same place, end at the same place, but it'd be going higher in the air or low in the air, depending on what the number is. Okay, so that's how I think of that. That's 2 times as high or something like that. It goes, but still same landing and starting point. And, all right, so I'll let you guys work. Ask lots of questions. Make sure you can do this on your own by the end of it. Don't just sit with someone and talk every problem through, because then you get the sense that, okay, I get this, but then once you have the quiz, you have to do it by yourself. So you're not going to be as sure. So do a few of the with some partners, check answers, and then do some on your own.